Okay, folks, I think we're just going to get started. We were expecting Dr. Ekstrom and others. I'm sure they'll mill in. So as I briefed this earlier today, A2PNT is one of the interesting outgrowths of a lot of the LEO-MEO SATCOM that's going on. And with that in mind, I talked about the fact that LEO SATCOM being proliferated may result in better performance than GPS. So obviously we can't go into the technical details nor the classified information behind that, but Jennifer from Zona Space will tell you a bit more about what's going on in their firm and their bid to launch about 250 satellites, is that right? So really impressive, a Bay Area company that's possibly going to change how we do GPS or GNSS. As you know, GPS is the only approved, FAA-approved system for flight of individuals like ourselves. But I'm hoping organizations like that will come around and realize that these commercial solutions, if not on par, may even be better. And you'll also hear from Link and a few other companies today. SpaceX is also doing some PNT work, but Zona and TrustPoint, I think they're doing some really exquisite work. So with that, Jennifer, if you want to come up. I'm just Jessica. What am I saying? Jessica. Sorry about that. Good.
For every time somebody called me Jennifer. All right, thanks, Bill. Hi, everybody. Got a small group here today, but I'm sure they'll be trickling in. As Bill said, my name is Jessica Halsey, and I'm with Zona Space Systems. I currently run sales and business development for Zona. Before this, I spent 16 years with BAE Systems, headquartered here in San Diego. So I've been supporting the Navy, Department of Navy, and the warfighter writ large for my entire career. But nevertheless, something about working for Intel and in large government programs for such a long time, I started to become a little bit enamored and jealous of the startup community and some of the advantages that they have in speed. And so with that, I found myself in 2022 with Zona and haven't looked back since. Let me tell you a little bit more about the team because they certainly, as Bill said, are impressive and are doing some really impressive things. So we have a pretty large founding team, as you can see there. And what these folks have at their core is they all matriculated from Stanford's GPS laboratory. And specifically, when they were there, they were under Dr. Brad Parkinson, who is arguably the father of GPS as we know it today. And so this is a very concentrated group of experts and individuals who also brought some experience from companies like SpaceX, Maxar, to bear as well. So since our founding in 2022, the team became the first privately funded satellite navigation mission in history with the launch of Hugin in May of 2022. You can see that payload in our lab there. And that mission successfully demonstrated Zona's high-performance navigation patent. And we've since moved into a larger office space complete with full ITAR lab and anechoic chamber, and we're gearing up for big things to come. I'll talk a little bit more about that. But first, I want to take just a quick step back and talk a bit about the history of GPS to get our mindset on what inspired Zona to go after this problem in the future. So one of the things is this article that was written in 2017 reflects all the way back in 1978. And this was before GPS was openly available, unclassified, and available to the public. And what we saw happen there is due to mind-boggling navigation failures, this Korean Airlines passenger flight wandered into Soviet airspace and was shot down. It killed everybody on board. It was a disaster, and it led to the US to realizing that this critical technology in GPS could have prevented this. And so since only such a short time have we actually had on the public side the civilian GPS signal that's available. And we could see in just less than 20 years the technologies that came out of that. We can see we've got up there on the left, those are some Navcom receivers. We've got the Nokia 6160. That was one of the first cell phones in 1991 that introduced GPS. We have a GuideStar nav model that's a little bit older, 1998, I think, and then a Magellan Nav 1000 portable unit. So in just a short amount of time, less than 20 years, you can see that the civilian community, the commercial community was rapidly picking this up. And now today, GPS is ubiquitously used in virtually everything that we do and touch on our day-to-day basis, as I'm sure you all understand. And so fast forward, we look at what are the 2025 needs from navigation technology that have evolved from decades of organizations designing around this gold standard. So obviously we've got automation, autonomous systems are increasing, the need for exquisite timing across greater distances, and we're really looking for a lot of these systems where we can remove humans from the loop. And so all of this means that the civil and commercial world is demanding better than what the GPS signal can provide today. And so that's where Zona Pulsar comes in. And it's important to underpin as I talk about Zona's design for modern technologies and the navigation performance that sits in the signal. I want to foot stomp and underpin that every design decision at Zona is made with the user equipment in mind. We are not bringing a receiver to market. So I know SpaceX is going to talk after me, and they're going to talk about Starlink, and there's a space plus a receive architecture, the big boxes that they produce and make, and you have to buy if you want to use it. We're taking an interoperability approach with our signal design. So we have dual wideband L-band signals that sit adjacent to L1 and L5. And the resulting signals are over 100 times more powerful than what you get from GPS today. This is a combination of payload innovations, payload technology that we've put on our bird, as well as benefits by operating in low Earth orbit as compared to GPS, which sits much higher in MEO and has some unique space characteristics relative to the orbit dynamics that make the navigation technologies that come off of those satellites fundamentally different. And that's a big thing to keep in mind as we talk about this. So we needed to get higher powered signals that worked indoors, that worked in increasingly contested environments, as well as additional accuracy in order to enable the precise automation that we need from systems today. So if you think about precision agriculture and needing to get these robots to have centimeter accuracy to get crops planted correctly, if you talk about what's needed to keep a car in its lane safely in all circumstances, the answer is satellite navigation technology. And so those were core tenets that went into our design. We also recognize, and I know you'll hear more about this theme if you're following any of the PNT tracks this week, is we are not a one-stop shop solution. So GNSS, the collective global navigation satellite systems that sit out there, most of which, aside from, I think Bill mentioned them, Zona and TrustPoint being a few that are out there doing this commercially in a dedicated way, take us away. Everything else are big government systems, right? So we have Japan, we have the UK, we have the US, obviously. And so we deliver through our signal in a bent pipe architecture ways to get at collective enhancements from all the space-based PNT systems that are out there. That's those GNSS enhancements being particularly important. And of course, security. We desire to monetize our signal. So that means we have to protect it. Authentication and encryption within the signals are a standard part of that offering. Not only does that help us protect the monetization of our service, but it also provides benefits such as integrity and the ability to understand if you're being spoofed or not. Or in this case, anti-spoofing protections directly come from our security model. Satellite availability. This is one of those benefits that just comes from being in low Earth orbit. We have many more satellites that are whizzing around at a much faster rate, so the collective picture of availability over a given point on Earth is going to increase by the LEO architecture that we offer. And then while many of our civilian commercial customers, well, most of our civilian, but definitely our commercial customers, they don't really care about GNSS independence. That's not something that's a big motivation to them. Certainly when we talk about the warfighter and the Dawn track objectives here, it's worth mentioning to you all that the architecture is capable of true GNSS independence. That is the fundamental tenet of our distributed atomic clock patent, is the ability to tie into these other timing backbones and maintain that accurate time. So let's take a little bit closer look at some of those benefits in the data space that comes out of Pulsar. So what we're seeing here is a comparison of Zona Pulsar to GPS. In this case, we're just looking at GPS L1C. And the way you can read this graphic, the red dot in the middle, let's say that is a white Gaussian noise generating box. So this is just a box that's going to put out a bunch of RF interference, and the effect is that it's going to jam the signals that are trying to be received on the ground near that jammer. What we can see here from these circles is that the teal colored circle, the smaller one in the middle, that is Zona Pulsar. So Zona Pulsar is, you would have to be very much closer to the source of jamming than if you were GPS in order to affect the receive capability there. Okay, so that means that if you have GPS, you've got to be somewhere all the way out in this area, outside this circle, right, in order to be able to do your tracking. You got to be way out there if you're talking about needing to demod, pick the signal up for the first time. If you have Zona Pulsar, you can be with anywhere, within these circles. So that's how you read these graphs. So this is actually showing, in this case, the benefits purely from having a higher powered transmit of the signal from space. So that's sort of, I think, pretty self-explanatory. Higher power means you have more resistance to jamming. Another thing I talked about is satellite availability, and this is typically an animation that's moving around in the center there, so my dots aren't moving. But essentially, if you take your view to the far right there, we're looking up in a bird's eye view in an urban canyon in downtown San Francisco. And so as the satellites are moving across the sky, in order to get a complete coverage picture, you can see with Zona's satellites, all that blue, that's our coverage. So over the course of time of 24 hours, it goes from using GPS and Galileo, two of our government sources, you get 70 passes, 70 attempts to do whatever you're trying to do with that navigation signal. If you add in Zona because of the LEO architecture, you can see, that goes up many factors there. So you're going to have an improved availability of navigation solution in all situations globally, and of course it's going to have these benefits, particular being evident in either urban or terrestrial canyons. So where are we at in our timeline? 2024 was a really big year for us. We secured several government contracts. We're very actively working with SSC Futures, SSC Commercial Space Office, the AFRL Rapid organization, to do some early testing and trade studies, analysis, modeling, and simulation to help us understand how we can integrate something like a commercial source of PNT into DoD operations, and what does that look like? How does it manifest? Is it certified? Is it a use at your own risk type of service? These are the kinds of questions that we are unpacking and exploring right now. We were our Dr. Tyler Reed there is holding the award from the Institute of Navigation for the Early Achievement Recognition, I believe it's called. And the ION Early Achievement Award, we were also named the 2024 Disruptor of the Year by TechCrunch. And we have formalized our relationship with our bus provider as we are gearing up towards the launch of our in-orbit validation mission for our production signals. So right now, there is an ecosystem of simulated signal technology available to allow for experimentation of Pulsar's technology. So going forward, our launch is in June of this year, and that is where we are looking to validate the broadcast of our new and improved L-band signals that I just talked to you about, and we're also going to be validating the integration of those signals onto third-party user equipment and some of those partnerships. And we're demonstrating early market use cases in that 2026 timeline. The service, you might wonder, how does one get a commercial service? What are those business models looking like? And so we spent a lot of time working with the receiver manufacturers to understand how they deliver GNSS, PNT technologies to market and have a flexible business model that is by subscription, or we can tie it to the length of term for a field that you need the fielded device to work in operation. And then there are different service levels as well. As I mentioned, maybe the commercial communities are willing to use PNT from space without the guarantees of authentication. So just use it and as a trust basis. Whereas we understand service level 3, we can build in all of the guarantees that would go with the service level agreement. And this shows our service rollout. So this year, we're going to do the in-orbit validation, and that also comes with the FCC license to broadcast the signal, which is a huge lift when you do that the first time. And then beyond that, once we get all of the IOV missions under our belt, we will start the aggressive rollout plan to get to what will eventually be 258 small satellites that will be putting down this service. We're going to start, you'll see coverage is going over a couple of key areas in 2027 with additional service rollouts happening through 2029. And then, of course, the GNSS independent architecture is something that is realized once we're fully deployed, and then we tie in some additional hardening measures to the timing reference. So that will be something that's at the end of our roadmap. This is the last slide I have here. And so since I talked a lot about how, Pulsar is going to show up in market and what motivated Zona to design and build the service, there's of course no shortage of modern technology needs that we factored into our design. But one of the things that we didn't design around was the threat. But I wanted to take a minute and kind of point out, if we look at that threat for a little bit and we apply Zona Pulsar, what kind of benefits do we have there? So first this is just a very, very short look back. This is only really going back to about 2022. And so we can see there counter-space weapons were confirmed by the Pentagon in this time. That's a CNN grab right there from the Russian Ministry of Defense. We have this GPS Jam website, which I pulled a recent grab up for this conference. This site didn't exist until July of 2022. It now exists. We also see here this spoofing graph. We have had the first attempted spoofing incident on a commercial aircraft in civil aviation happened in February of 2024, not yet a year ago, and they were counting maybe handfuls of them. That's what you can see on the graph. We now have 1,000 a day spoofing attacks that are happening to civil aviation flights. And they are coming clearly from certain regions of the world, as you might expect, but nevertheless, this is now a problem. And so FAA certifications aside, and how do we integrate, this technologies to solve this problem, right? We've got to look at a holistic P&T approach in order to get around this. And then, of course, because we're working so closely with SSC, they finalized their 2026 Resilient by 2026 strategy. And of course, I think we all understand and know, what the threats are that associated with that. So the threats are on orbit, they're on land, they're affecting, of course, not just the warfighter and the operations there, but that technology is now spilling over and it's affecting everything as you can see in our civilian lives here as well. And so this is something that we're hoping Pulsar can plug into when we're on orbit to help. And with that, I thank you all for your time. And Bill, am I taking questions? Any questions? I think we can. Oh, okay.
Thank you, Bill. I ran out. So, with my Space Force, teammate over here in the room, the threat is real. Resilient by 2026. I don't know if Bill or Vince know, but I'm curious, have you done in an unclassified forum like this any comparisons between what Zona has a potential to provide with respect to resilient PNT comparison to military code from space? Because we have had some challenges with integrating that capability into our platforms, and you sound like you might be a receiver agnostic or platform, like you said, you're all about integrating with what's already out there. So I'm curious if there's any comparisons yet that you could talk to.
Yeah, I can generally talk about the comparison. So M-code is great, and when you can get it on the receivers, you are going to get a significant boost. And so if you look at those power numbers, and these are in the unclassified domain, we're just now in the process, Zona is, of going through our FCL for the first time. So we have to deal with everything in an unclassified domain. There is information out there. We have done the comparisons. We are about right close to like what you would expect from that DB power to what an M code is, but you hit on it with the receiver agnostic, which is that's what we desire to be. Is that unlike the rollout problems that exist for very good reason and not throwing rocks, but user equipment's hard. Rolling out M-code receivers is hard, right? The requirement, do we lock the requirements down too much? Do we leave, room open? All of those discussions and trades are, of course, shifting around. So the best that we can do is offer the comparisons and trades and give the warfighter and our allied forces, right? So if this, as Zona Pulsar is a dual-use ER 99 commerce-governed solution, I don't need a foreign military sale to get this in the hands of our allies. And so since we know we're going to be dealing with a collaborative battle space in these theaters, that is one of the advantages, because you're never going to get M-code to them. But you can get Zona Pulsar and you can have the comparable anti-spoofing and jamming protections.
That's a real good answer. I appreciate that, because not only, there's issues with laying M code receivers, but now we have to touch every single GPS receiver on every single platform to include things that go boom, right? And if we don't have to touch it with Zona, I think there's a potential other path or another option, as we move forward. So thanks for that. I look forward to the teams looking closely at that with respect to comparing, Zona capability with what we have from a programmatic perspective. That's all. Thanks.
Hey. I'll leave a couple of my cards with Bill, so feel free to reach out to me, keep the discussions going. We love to host the government at our shiny office in Burlingame, so happy to take me up on that as well. Thank you, Bill. Enjoy the rest of your afternoon, everyone.
Thank you, Jessica. So some comments. We've been working with Zona and others to try to ease that integration that the captain talked about. So among those things, for the fleet, we use GPNTS, GPS-based position, navigation, and timing services. And we've shared ICDs, such as the OD19 message types and such. Therefore, it would be a receiver that would feed our system, and we either would fuse it or, well, maybe select it over some other sources. But so we're discussing early integration and shaping their user terminal elements. In spite of that, getting anything on a ship is a rather onerous process. And Vince, our tech director, would probably tell you it's going to be a 75,000 to 150,000 per ship, plus all the other workup. So engaging with the vendors early is the right solution. And someday we will pony up the bucks that we should. And but the investments, as I've said earlier today, it's all been on industry, which is a pretty remarkable feat, given that we just push forth not requirements but desirements. So, all right. So, folks, yes.
Again, all those GPS receivers and pucks out there that we might not even know exist. Right? I mean, we've talked about the challenge that we have with understanding the vulnerability of our platforms to the threats in GPS. And we realized years ago, and I know Bill knows this, that we were trying to track every single GPS receiver just on our platforms, and we didn't know where some of them were, and they didn't have a path to protected GPS. So I'm just saying that's some of the unknown unknowns I think we're still worried about today.
Right, sir. And by the way, we also have Larry Brandhoover in the back there. He works on what's called interference excision systems, and we are trying to protect our GPS signals. So we haven't given up on GPS. It's the premier system that we work with. And if you have ideas on how to make GPS better, we're open to that. But solutions like the Zona system brings a whole new level of performance. I'm a little bit liquored up on this. All right, great. All right, folks, we'll come back in about 15 minutes or so, and SpaceX will give us a rundown on their Starlink constellation. Thank you. Okay, folks, if you could take your seats. So our next presenter is Chris Elder from SpaceX, a small little startup that forgot that they gotten big. And with that, they've been doing quite a bit of work for us. As I mentioned this morning, they've been supplying us quite a bit of capacity. We went from kilobits to megabits to gigabits, and who knows what's next. So with that, Chris, I don't think any further introductions are required. Pretty dynamic company, and take it away.
Yeah, thank you, Bill. Can everyone hear me okay? Cool. I'll try to speak up, so if I don't, throw something at me. But as Bill said, here from SpaceX, I support Starshield and our government aviation kind of verticals. Going to talk a little bit today about Starlink, and then, yeah, happy to answer any questions that you have. So I think kind of starting from first principles, I think everyone kind of knows what SpaceX is, a space company. It's in the name, but really kind of our cores are rockets. Everything we do is built upon that foundation of having good rockets that enable us to do other things like human space flight, as you can see there, and then our constellations with Starlink and Starshield, and then Starship, which is the next iteration of what we're trying to accomplish from a space vehicle perspective. But the through line, I think that you can see from here is just that reusability, driving down cost and allowing us to scale by kind of harnessing that reusability, starting with our rockets, our boosters, and then with Starship, that both the booster and the rocket are going to be reusable. So pictures are worth 1,000 words. You can kind of see the evolution of our rockets, our Falcon 1, which was our first iteration, all the way up to Starship. The Falcon Heavy is for most of our kind of national security launches. It's got Falcon 9 rocket and then boosters on the side, but just gives you an idea of kind of where we were and where we're going. And I've got a video here. I don't know if the sound is
All
going to,
stations verify.
okay, the sound
ready
is
for
going to work,
launch.
so I'll let it.
FTS. FTS go. Props go. AVI.
AVI's go.
GNC.
GNC go.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
SpaceX is go for spacewalk operations.
So yeah, I think it does a pretty good job of showing a lot of the different things that we do. Commercial space flight, something I didn't really touch on, but you could see at one point the nominee for NASA did a spacewalk for civilian spacewalk. So lots going on, but we can kind of dive into Starlink. And if you have questions, please let me know. But background, Navy intelligence officer, so what I'm not going to do is read from the slide, because if I do that, someone somewhere is going to come down and get me. But I think one of the takeaways from the slide is just scale. You know, we talk about scale for the things that we do. I'm based in our Redmond, Washington office, where we build our Starlink sats. You can see we push out about 50 per week, and we've surged up to 90 in the past, just to see what we were able to do in extremis. You can see just, again, how many sats we have on orbit, as well as like the number of users, and we're able to do that because of our scale, our ability to get tonnage into space cheaply and effectively, and then just our manufacturing that we do, sats in Redmond, and then in Bastrop you can see just pushing out the user terminals as well. So just really leaning into that idea of scale. So this isn't a mock-up. This is actually a screenshot in time of our constellation. And one of the things that we're trying to do with a proliferated low Earth orbit is, you know, getting greater density. That's in the number of satellites you have, and then that's also in the advances that we make to the actual satellites themselves to give them greater capacity. And we're able to get bigger sats on orbit by having larger space vehicles. So our Falcon 9 rocket, if we're only going to do a Starlink launch, you're looking at about 24 sats in the fairing. Starship, we'd be looking to launch our version 3 satellites with greater capacity, and we're probably looking at 3 times that number of satellites. I do think that it's notable. One of the questions we get is, do you have pole-to-pole coverage? The answer is yes. You can see we've got sats on the 70-degree sun-synchronous orbit. Most of them are in that 53-degree inclination, because that's where most of the population of the Earth is. But we are able to do full pole-to-pole coverage. And to give you an idea, just talking about getting sats on orbit, last year we did 135 Falcon 9 launches. They weren't all Starlink. Also doing rideshare, also doing national security. But our goal this year is to do 175 launches. So just showing you putting a fine point on the cadence that we're trying to hit and the goals we're trying to set. It's ambitious, but for us, that's the way we can continue to scale and we can continue to provide value to our customers. So I'm going to walk through our architecture. Please, yes.
You finding commercial viability by with your pole coverage, or is that mostly to help out the nation?
It's both. So where we see a lot of applicability are for scientific research in the North Pole and Antarctica, aviation, particularly going over the poles. So commercial aviation, business aviation, and obviously from a military context, it's incredibly important. We've done a lot of commercial aviation are using the poles because it's more efficient fuel-wise and you can get there quicker. And so, yeah, they want to have their streaming coverage over that. So there's a there's a commercial use case and obviously a national security use case. I think the national security case probably came first, and then the commercial followed. But there's a use case for both. So this is walking you through our architecture. It's admittedly an oversimplification, not to insult your intelligence, but just to give you a general framework of how Starlink works as a constellation. So I will add, kind of like with the last slide, the globes you're going to see in the upper left corner. Those aren't mock-ups. Those are actually screenshots of our constellation in time. So it's not a mock-up. But going right to left, starting kind of with our antennas. So all of our antennas are KU band, and they're flat electronically steered arrayed. So the antenna you see here on the ground, that's one of our commercial ground terminals, but our aviation terminals, our terminals that we use for maritime environment, and even in space on Starship, they're all flat electronically steered arrayed. So you can see the frequencies that we operate in from the downlink and the uplink for KU, but those are the frequencies we operate in. And then that picture on the upper left, what that is showing is all of our satellites putting down KU beams to service terminals. It doesn't go. We divide the Earth into hexagons. They're roughly 22 kilometers in diameter, but those beams are going to those hexagons to provide service. So I think Bill touched on this earlier today, but one of the things that kind of allows us to have this high-speed, low-latency connectivity are our optical intersatellite links. So starting with that globe there, you can kind of see those blue lines. Those are our optical intersatellite links that are equipped on our satellites. We have about 7,200 sats on orbit and growing. Probably about 95% of those are equipped with our optical intersatellite links. And what that enables us to do is effectively create a mesh network in space. You're able to move roughly 100 gigabits per second via those optical intersatellite links, namely because physics. The speed of light is what it is, and so we're essentially putting, we're expending capex to build this capability so we can move data quickly. And where that's really beneficial and been impactful, particularly in this context, is in the maritime environment, but also in aviation. So in a traditional transponded service, you'd have to be in a particular area. Our traffic can be routed pretty much anywhere on the Earth via these optical intersatellite links if that's the most effective pathway. The one example I'll give, if you were here last year, now Captain Kevin White was talking about the Abraham Lincoln. We've got Starship terminals on the ship. They went underway in January of 2023, and they streamed the Super Bowl in 1080p on a 1,600-inch screen, I believe, with about 1,800 devices on the network at the same time, and they had no issues with latency. So it's a bit of a paradigm shift in what the capability can provide, obviously in that context, but in others as well. So once the traffic goes from our sats down to our gateway sites, we have about 200. I got to update that slide. I think we have about 240 gateway sites distributed around the Earth, and think of that more as like a fancy media converter that's turning the light energy into data, as opposed to more transponded service where there's encryption and things going on at that point. It's just it's a pathway to get the data from the gateway site to an internet point of presence. And so for that internet point of presence, we do have leased fiber that we use, but in some instances, data will travel mostly over our optical intersatellite links and down to a gateway site and not use leased fiber. The network is really, it's primed to follow the most optimal path. And so if that pathway is through the space layer, we'll do that. If it's through leased fiber, we'll do it that way. It's just dependent upon where the terminal is and where it's trying to go. So global licensing, you can find this at our website, starling.com/map, but it shows where we have commercial licenses. As you can see, most of the globe, we're working towards getting service. We have the top line, coverage is live in all international waters because it's a question that we get. But a lot of our growth has been in that maritime environment where people want to have that kind of connectivity underway. So this, you may have seen this. This is a video of Starship coming into orbit. And one of the questions we get is, are you able to maintain connectivity with your satellites with objects that are moving fast? Starship, as it's doing its re-entry into atmosphere, is going about Mach 23. So we're able to stream this video. We're able to stream this video and show the plasma coming off of the ship when, previously we wouldn't be able to do it. We're able to do that leveraging Starlink and antennas that we have on the ship. So a couple national security use cases I can touch on. We do a Starshield webinar if you're interested in learning more about Starshield, that we're happy to get you the information on that. But just want to kind of touch on a couple things that we're doing from a national security perspective. So we've been working and we've been partnering with the Navy, Bill, AFRL, and other organizations just to try to find utility and use cases for commercial satellite or commercial SATCOM. So that started with AFRL, with Global Lightning and the DUCY program, if you guys are familiar with that. But really the intent was, how do we use ComSatCom to supplement other capabilities that we have to give the warfighters everything they need to have a decisive advantage? And you can see kind of the growth and the increase in getting Starshield out to mission partners. And Bill kind of touched on that earlier. There's different mechanisms to do that, but really good IDIQ partners with CSSC2 and the CSTO office, but just providing a venue and a capability to get this out to warfighters who need it. And then here, just some quick pictures of different use cases. On the right, that's actually the Abraham Lincoln when she was in port. Captain White took me out to the ship last year to see it. But you can see the terminals on the port side of the ship. And then obviously you can see the other ones. The top left is near and dear to my heart. VX-30, based out of Point Mugu, wanted to do a rapid prototype. And they put one of our aviation terminals on the aircraft and they flew in gray flag. And it's pretty cool just to see the capability that they were able to not only use for their use cases, but also showing how they could be a comms relay pathway as well. And then this is another video that we've done. This is from a couple years ago. I want to say it was 2020. But we're streaming a Starlink satellite launch on a tablet. One of our engineers is filming that using a Starlink antenna on top of the aircraft while we're refueling an F-16 in flight. So it just gives you kind of a tangible example of the capability that you have, in flight, you can stream video. And no, you're not always going to be streaming Netflix or watching your cat videos, but if you have that kind of throughput and that capability, it unlocks different use cases for U.S. government and for different mission sets. So just wanted to show that as well. But kind of the slides I had today, I went through it a little bit quickly, but happy to answer any questions that you may have.
Chris, can you talk about where these things are made?
Yeah, sure, Bill. So we have two different facilities where we make our user terminals, both in Bastrop, Texas, and then Hawthorne, so about 2 hours up the road in LA. We push out, I think Bastrop was 70,000 terminals per week. And we had a tour back in December where, if you guys are familiar with our smaller form factor, the Starlink Mini, we produced 10,000 of those in 6 hours when we were trying to push to see what we were able to do. So we've got manufacturing both in Hawthorne and Bastrop for the ground terminals, and then for our aviation terminals in Hawthorne and in Redmond. And then we manufacture our rockets out of Hawthorne. We do our test firing in Texas, and then Starship is being built and produced out of Brownsville, Texas.
I asked that question because when I first visited SpaceX and watched their terminals being built, I saw a few parts that were made in Taiwan and commented on that. And the next time I visited, it was all made right there. In Bastrop, they do the complete manufacturing, PC boards and all.
Yep.
Thanks. Yeah, hi, Clifton Phillips with you, a small company called Aegis Space Group. On your architecture slide, can you comment on the AES key encryption methodology? Does Starlink hold keys, or can a government customer hold keys? And just how is the enterprise management and control done with respect to the two boxes that have the 9s in them Over.
No, that's a great question. Thank you. So for Starlink, our commercial ISP, we have AS128 encryption, so that's end-to-end. For Starshield, we're looking to upgrade that to AS256. But with respect to, additional security and capability, you have the ability to add additional encryption if it meets your use case. We do have government partners that are using like a HAPIS device and or a TAC lane to facilitate high-side communications, but fundamentally it's commercial black transport. So we provide that end-to-end encryption at AS128, but we certainly encourage people if you need additional encryption to add it, but it's complementary to any encryption you want to add to it.
Just to comment on that, so Clifton, as you know, in spite of the security that's built into this thing, the Navy does not trust this network. It's part of that zero trust, which is going to come later, but we have what's called commercial SATCOM as a transport, CSAT, and we overlay HAPIS, IPsec, and a few other things, which we can't get into here, but it's proved to be so far pretty robust. NCDOC, Navy Cyber Defense Operations Center, have been looking at this. They have some recommendations, and SpaceX, they've been pretty open about working to address some of the issues. I'm not going to say vulnerabilities, issues. So it's been a really good cooperative engagement.
So, two questions. The first one, when I hear that Starlink is leasing fiber, it doesn't resonate well with me because Starlink and SpaceX are so vertically aligned. Is that just the way that it has to be for you with respect to all your gateways across the globe? That's just a fact of being in these different countries, and you expect that to grow?
Yeah, that's a fair characterization. I do think that as we get more sets on orbit, and as traffic is flowed based on the optimal path, we very, very possibly could use the space layer more than we would lease fiber. But for right now, yeah, it's just the most easy way to get data to where it needs to be.
Okay, that's what I figured. It's been a while since I talked with Kevin, I think at the last Slam Time back in Monterey. We talked to them about assured alternative PNT as a possibility. Is that something you're looking into as providing as a service via your Starlink system? Is that something that you've done? I've lost track.
No, it's a good question and one we get frequently. The short answer is, yes, we're looking at a couple different options. We've been partnering with Space Systems Command just to determine the viability of it. Obviously, we have 7,000 sats on orbit for Starlink, and so it's an area where we think that there's a lot of opportunity and capability, and so we're just exploring that with them just to figure out like what makes sense, what's viable, and then kind of go from there.
Adding some color to that, we've had UT Austin look at their constellation and the waveforms and such. In fact, without any knowledge of the waveforms, they've reverse engineered it out, and they found, as a technique called signals of opportunity, they're achieving single-digit meter scale accuracy. And I think that's attributable to some of the OISL work that they're doing. It is so high speed and so precisely flown that you're going to have incredible time. So Professor Todd Humphreys have been doing that. You can look up the papers he wrote. Pretty impressive. I'm waiting for SpaceX to make that as a service. Just another quick question. What's the longest optical link you have shot so far? Actually, I know the answer.
What is it, Bill?
It's 5,400 kilometers. Want to know why?
I do.
Curvature of the Earth. Yep, gets in the way. So apparently this OpenZR Plus standard is capable of going further. I'm real big into that. Big fan.
I didn't know that one, so thank you.
So Bill touched on the OISLs, and that's a critical capability of benefit to us to achieve the comms resiliency. Can you talk a little bit about How, yeah, I mean, you've developed that internally, vertically integrated. How you got to OISLs, and just talk a little bit about how they operate from a resiliency perspective, the ability to route across the satellites. It's a key benefit for the Navy.
Yeah, I know that, OISLs is not something that we invented. It's not something that was new, but I know as they were building out the constellation, the thought process was if we want to have density and we want to have scale, figuring out this capability, as other companies have done as well, it's value add. It gives you greater resiliency, greater capability. So it was something that I think from the early days, it was something that we focused and prioritized. With respect to the network, I'm going to answer your question. If I go too far off to the side, bring me back. Sometimes I go down the rabbit hole and I'll try not to. But to give you just kind of like a vignette that probably speaks to it well. So at any given time, there's between 15 and 20 satellites within your field of view. It's probably a little bit higher now, but the way that the network works, if your terminal is if you have a terminal underway at sea, and there's some kind of blockage, whether it's a mast on a ship, whether it's any kind of anomaly, the system's going to automatically fail over to the next satellite, so it's going to go to the next one. So, and that's applicable to an obstruction. That's applicable to going beyond the horizon where you've got to pick up a new one. So it's constantly dynamic, it's constantly moving. And so with that in mind, if there's a broken link with one of our intersatellite optical links for any number of reasons, Murphy or what have you, the network is going to route your traffic through the next optimal path. So whether that's, if there's a couple sats that are down for some reason, it's just going to bypass those and go through another one. Or conversely, if you're within if you're within a range of a gateway site, maybe it just goes straight down to the gateway and runs through fiber. But it's dynamic, it's transparent to the end user, and there's no tuning. It's just the network is going to identify the optimal path. So, yep, yeah. So if you have yeah, it's all automatic. Sure.
Can you comment on direct-to-device? Obviously, you guys are offering the ability to use any device, I assume.
Yeah, the direct-to-cell is a really cool feature that we've added. And so effectively what we're doing is creating cell towers in space. So our satellites that are manufactured in Redmond, we're adding transmit and receive to be able to receive cellular devices. And so what we've done is we partnered with a variety of different telecoms around the world, T-Mobile in the United States, KDDI, and a couple other ones. If you go to our website, you can see what those companies are, or excuse me, what those telecoms are. But what we're doing is we're taking the constellation that we have on orbit and then creating that ability to have a direct-to-device. So if you're in an area where you don't have cell coverage, you can go up to the satellite and down. The intent is to have SMS text throughout the continental United States this year, and where we have connectivity in other countries with their telecoms. By the end of next year, we want to try to have voice and video, and then beyond that, being able to support IoT. So it's definitely an area that we're really excited about. Most of the kind of applicability and the using it for any users resides with those telecoms because they own the frequency and the spectrum. Or excuse me, on the spectrum, not the frequency. But we're basically, for lack of a better way of describing it, we're cell towers as a service in space.
So are the Starshield and Starlink network architectures the same? Does Starshield use CGNAT? Like, how are they different?
So they're two separate and distinct constellations. However, the kind of the architecture that we use and that framework that you see right here, it's not the same, but it rhymes. It's very similar because we're looking for those efficiencies and that scale. So everything from the satellites are going to be very similar because we found a way to mass produce them as needed. From a CGNAT perspective, we do provide that capability, and there's a little bit more network configurations that you can do on the Starshield side that you can't do on the Starlink side.
Like controlling your ground station? Or is that something you can work with government customers on?
Controlling your ground station, not as much. We do have the ability to where in certain locations, if you need your own gateway site, there's the ability to do that. And that's done if there's like, it's done both on the commercial and the StarShield side. Basically, if you're in a location that's very austere and you don't have like, you know, you don't have fiber, you don't have that kind of connectivity, that is a feature that we have as a community gateway on the Starlink side and then on the national security side as well.
Thanks.
Anybody else?
Yeah, great brief. The optical communication terminals, you guys announced that you're selling them to other companies. Have you done that to date to other companies?
Yeah, it's a new feature we're looking into, just providing, we call it plug and placer. But effectively what we're doing is like talking to different companies, whether they're, you know, space layer or otherwise, and saying that we can provide you with our optical intersatellite links so that you can leverage the mesh network that we've effectively created. It's still kind of early days, but it's something that we've started doing, yes.
But if another company wanted to create another constellation and not be part of your ecosystem, but just use your optical heads, that's someone that you would sell to?
I'm not entirely sure, and this isn't meant to be a cop-out.
That's okay.
It's not the focus that I have.
Yeah.
I think we're always looking, there's a lot of different companies out there looking to do their own constellations, and we've talked to a lot of them, whether it's providing launch to get them onto orbit or looking for, you know, business use cases that make sense to partner together. So I wouldn't go so far as to say never. I'm not sure what's been done so far.
And lastly, compatibility with SDA transport layer. You don't have that today. Is that something on the roadmap, or can you comment on like the philosophy behind what they're doing, what you're doing? I'm just curious.
Yeah, I'd say I'm more on the terrestrial side than the SAT side, but we were part of Tranche 0 for SDA, and so we have participated in that. The discussions that have been had, like for, you know, Tranche 1, Tranche 2, I'm familiar with it insofar as I know what SDA is trying to do. Our teams that work on that and partner with SDA, happy to get you in touch with them, and they could speak more authoritatively about it.
Great, thank you.
Sure.
Okay, I think that's wraps it up. Thank you, Chris. Let's give you a round of applause. Okay, so just actually interestingly, the directed device is becoming a real burgeoning field, and so at 14:45 we'll return here for the AST Space Mobile, and of course Link is another company that's doing this. One of the neat things about flying low is that the latency is sufficiently low enough that you're within the ITU G.114 150 millisecond limits for voice communication. So towers out in space is going to become the next big thing. So please come back for the AST Space Mobile brief at 14:45.